Electricity used to feel simple. You flipped a switch, the lights turned on, and the bill arrived once a month. But today, many homeowners are starting to question how much they depend on the power grid and how expensive that dependence has become. Energy prices have been rising in many places, and people are beginning to explore ways to produce at least part of their own electricity. Three options usually appear in these conversations: solar panels, small wind turbines, and DIY energy generators. Each one promises a way to generate electricity at home. But they work in very different ways, require different conditions, and produce different results. Understanding those differences is the first step toward deciding which approach actually makes sense for a typical household. Solar power is often the first solution people think about. Solar panels generate electricity by converting sunlight into electrical energy. When sunlight hits the photovoltaic cells inside the panel, it creates a flow of electricity that can be used by the home. The idea behind solar systems is straightforward. During the day, the panels produce electricity. That energy can power appliances, charge batteries, or in some cases even send excess electricity back into the grid. Solar power has one major advantage: it operates automatically. Once a solar system is installed, it requires very little daily involvement. As long as sunlight reaches the panels, they continue producing electricity. However, solar power also depends heavily on location and conditions. Homes with limited roof space, heavy tree coverage, or frequent cloudy weather may produce much less electricity than expected. Solar panels also stop producing power at night, which means many homes still rely on the grid during evening hours. Another factor is installation cost. Solar systems usually involve several components beyond the panels themselves. These include inverters, mounting structures, electrical wiring, and sometimes battery storage systems. Professional installation is also common to ensure safety and compliance with electrical regulations. Because of these requirements, the upfront cost of solar systems can be significant. Wind energy is another option that people sometimes consider. Small residential wind turbines generate electricity by converting wind movement into mechanical energy. When the wind spins the turbine blades, it turns a generator that produces electricity. Wind systems can work well in locations where wind speeds are consistent and unobstructed. In open rural areas or coastal regions, small wind turbines may produce steady amounts of electricity throughout the day and night, but wind power also has limitations. Unlike solar panels, wind turbines require sufficient wind speed to operate efficiently. In areas with calm or inconsistent wind patterns, turbines may produce very little electricity. They also require proper placement. Turbines need to be installed in locations where wind flow is not blocked by buildings, trees, or other structures. Noise, maintenance, and local regulations can also affect whether wind turbines are practical for residential use. For many homeowners in suburban environments, wind conditions are not always ideal for small turbines. Because of these limitations, some people begin looking into a third category: small DIY energy generators. DIY energy generators are usually small systems that individuals assemble themselves using basic electrical and mechanical components. Instead of relying entirely on sunlight or wind, these systems are designed to generate electricity using simple setups involving motors, alternators, batteries, and wiring. Many of these systems can be assembled in a workshop or garage using widely available parts. The main appeal of DIY generators is flexibility. Because the system is built by the homeowner, it can be modified, expanded, or adjusted over time. People who enjoy learning about electrical systems often find this approach interesting because it allows them to experiment with different energy setups. Another advantage is cost. Many DIY generator systems can be assembled using relatively inexpensive parts compared to full solar installations or wind turbine systems. However, DIY systems also require technical knowledge and careful assembly. Electrical safety is important, and poorly designed setups can create risks if they are not built correctly. In addition, most DIY generator systems produce smaller amounts of electricity compared to large solar arrays or well-positioned wind turbines. They are usually designed to supplement household energy rather than completely replace the power grid. When comparing solar, wind, and DIY energy generators, it becomes clear that each option works best under different conditions. Solar panels are often most effective in locations with strong, consistent sunlight and sufficient installation space. Wind turbines perform best in open areas with reliable wind patterns and fewer obstacles. DIY generators can be appealing to people who want a lower cost, hands-on approach to experimenting with small-scale energy production. but none of these solutions automatically replaces the power grid for most homes. Instead, many homeowners combine different strategies. They improve energy efficiency, reduce unnecessary electricity usage, and explore ways to produce small amounts of power independently. Over time, these small steps can reduce how much electricity a household needs to purchase from traditional utilities. The most important insight is that producing electricity at home is not about finding one perfect solution. It's about understanding how each system works and deciding which approach fits your environment, budget, and level of involvement. Solar, wind, and DIY generators each represent different ways of approaching the same goal: gaining more control over how energy is produced and used at home. As technology becomes more accessible, more homeowners are learning how these systems operate and exploring ways to participate in their own energy production. Electricity will always remain essential for modern living, but the methods people use to generate and manage that electricity are gradually becoming more diverse. Understanding the structure behind these systems is what allows homeowners to make informed decisions about how they want to power their homes in the future. If you found this explanation helpful, consider subscribing to the channel for more videos that explore how home energy systems work and how people are learning to manage electricity more efficiently. And if you're interested in studying the basic structure behind small DIY energy generators and how some people assemble them using simple components, there's a useful resource in the description that walks through the parts involved and how these setups are typically organized. Wide shot of a kitchen table with several printed electricity bills, a calculator, and a notebook under soft indoor lighting while a person sits reviewing the papers. Close-up of hands holding an electricity bill while comparing numbers written in a small notebook. Side angle of a person sitting at a home desk with a laptop open while reviewing electricity costs. Overhead shot of a garage workbench with a notebook containing simple sketches of home energy systems. Wide shot of a clean residential garage workshop with tools organized on the wall and a wooden workbench in the center. Medium shot of a homeowner examining electrical components and cables arranged on the workbench. Close-up of a small solar panel placed flat on the workbench while the person inspects its surface. Side angle of a person holding the edge of a solar panel and positioning it near a garage window with daylight. Wide shot of a backyard area with a small set of solar panels mounted on a simple ground frame. Medium shot of a homeowner adjusting the angle of the solar panel frame outdoors. Close-up of wires running from the solar panel into a small inverter resting on a table. Overhead shot of the inverter connected to cables and a battery on the garage workbench. Side angle of a person tightening a wire connection on the inverter terminal. Wide shot of an open backyard area with a small residential wind turbine mounted on a short pole. Medium shot of the homeowner observing the turbine blades rotating slowly in the wind. Close-up of the wind turbine generator housing and connected wiring. Side angle of cables from the turbine running toward a battery system inside the garage. Overhead shot of the battery and wiring connections arranged neatly on the workbench. Medium shot of the homeowner examining a small alternator and motor assembly used in a DIY generator setup. Close-up of hands adjusting bolts on the small generator mounted to a wooden base. Side angle of a person connecting wires between the generator and a battery on the workbench. Overhead shot of tools, wire spools, connectors, and switches organized across the table. Close-up of a hand using a screwdriver to secure a wire terminal. Medium shot of a small lamp connected to the DIY generator system on the workbench. Close-up of the lamp turning on while connected to the generator wiring. Wide shot of the garage workbench showing solar components, generator parts, and tools placed in separate sections. Side angle of a person comparing hand-drawn diagrams of solar, wind, and generator setups in a notebook. Overhead shot of the notebook with simple energy system sketches and measurement notes. Medium shot of the homeowner standing beside the workbench observing the assembled components. Wide shot of the entire garage workshop with soft daylight entering through a window while the person stands near the workbench reviewing the energy setups.